Today, we're going to talk about the best practices in project management, and it's going to be specific to the medical device industry. Medical devices and IVDs have a requirement called design controls. And unfortunately, back in 1996, when they first required the design controls to be implemented for medical devices, they used a very old, antiquated diagram, a waterfall diagram. It was actually copied with permission from Health Canada, and Health Canada didn't even develop it. It was actually in the ISO 1994, ISO 9001 1994 edition for quality management systems. So they borrowed it from somebody else who borrowed it from somebody else who didn't even develop it. It was best practices back in the early 90s on how to do project management. So you would have a stage gate process. This is traditional project management techniques. And we would make sure that you couldn't go on to the next phase of development until all the deliverables for the previous phase had been completed and management signed off on, yes, you're okay to go to the next phase. And part of that was because we didn't want people spending money on the next phase of development if the project hadn't finished the goals and deliverables for up to that stage. It was just a management technique to manage your resources and your money and decide which projects we're going to fund now versus we'll wait a little bit until you're further along and you finish all your deliverables, then we'll make sure that we can fund that. And some of it was also to make sure that they had actually made sure that the project was feasible, whether it was legal, whether there would be any unforeseen regulatory hurdles. There was a good reason behind it. But there's a lot that's changed in 30 years. So over a 30-year period, now the mainstream methods have gone from traditional project management tools using the waterfall approach to agile methodology, which is an iterative or dynamic project management approach, to now hybrid methods, which are a mixture of the two. So it's really important to understand what is the difference between a traditional or waterfall process, an agile process, and a hybrid process, and when you would use each and how they relate to the medical device industry. So at the very basic level, waterfall process, they show a waterfall. They show the different phases. They have the planning stage, then you have your inputs, you have your outputs, you have your verification and validation, and you have your final review and release of the product. And it's a linear process. It's not iterative, it's linear. Projects don't ever go that way, ever. I mean, I suppose if you had a really simple revision of an existing product and a product improvement, maybe you could have a small tweak and it would be linear. You'd do one iteration, you'd be done. But most of the time we have to try something out, see if it works. It sort of works. Some things work, some things didn't. Try again, try again. 6 or 8 times later, we actually get to something that's going to be the final version that's going to work. We call that iterative. That's reality. So even though that occurs in the middle of development, we still call the project management process traditional if you're not allowed to go to the next phase. If we say there's a hard gate here, you're not allowed to go to the next phase until you've passed all these deliverables. And but they sort of ignore at the high level planning stage that there's going to be iterative things going on here, and it doesn't really reflect that reality. In the agile process, everything is supposed to be dynamic. We're supposed to have an iterative process, and they actually draw it as a circle versus a line with arrows that are sequentially numbered. Step 1, phase 1, phase 2, phase 3. Instead of that traditional approach that's linear, agile is circular. And each time you go around the loop, oftentimes you're adding in new features to the product. So a lot of times they go with what is called the lean approach that was popularized by Eric Ries or Rice. In that process is you have a minimum viable product. Before you try to go for the ultimate product that has all the bells and whistles, let's at least get the minimum viable product on the market. and get it approved by the FDA, get it cleared by the FDA, and see if it is popular with customers. And so the customer may say, well, what it does is nice, but I wouldn't buy it because it's missing this key thing I need. So those are the things you learn by iteratively going back to customers. You try your concept, your key differentiator that's going to be different and an improvement on everything else out there. You make sure that works, but then you ask the customer, well, would you buy this as is, or is it missing something you need? And so they would tell you, well, it's missing this. So you add that feature, and you get more feedback. Yeah, we'll add this feature, but eventually you get to the point where, like, yes, I would buy that if the price was right. I'd buy that product. But you want real feedback from customers, real customers. You often want them to pay for it. I mean, people always tell you what you want to hear. Yeah, oh, that looks great, but I would never buy it. That's not what you want. You want them to actually buy. So that's why we do beta testing sometimes. We have people we sell them our beta version of a product to see how it's going to work. And then we'll fine tune it and polish it and relaunch as a final version. But those early customers, the early adopters, gave us feedback that really directed the product development, and it made the final product what it is today. So when we're thinking about this agile method, we're talking about a circular dynamic development process that's iterative, and we're probably going to add features as we go. So if we're in the software world, which is where agile methods came from, we would add a software requirement spec or multiple software requirement specs each time we go around the loop. So one of the things that we use, and so there's a lot of jargon involved in project management. We have something called sprints in Agile. A sprint, and really actually that term is from Scrum teams. So it's a different variation of these dynamic Agile project management approach. But Scrum, and I'll use them synonymously or interchangeably in this presentation, even though they're not really. But sprints, think of that as I'm going to add these 3 or 4 software requirements, and I'm going to do another iteration of the product with those 3 or 4 requirements. That's a sprint. And every single one of those software requirements would be what they call a story point. So I have one developer working on one story point, another one working on another story point. Each of those user stories, it's another term we use, each of those user stories is a function that we're having a programmer either improve from the previous iteration or add that wasn't there before, or maybe even take it away and see if they like it without that feature. That's a neat way of doing it. Or maybe just presenting it in a different way. The graphic user interface might be different. So those are things. Okay, somebody actually corrected me already here. Story points are actually to convey the complexity of the task. So yes, there's actually several considerations. Also the risk involved, the cost, the time. There's a lot of different pieces or magnitude thereof. Thank you, Raphael. So yes, so you have these story points, or that would be for the different things that you're going to be doing during these sprints. And one of the ways we measure how fast these agile projects are going is we measure the velocity of the sprints in the number of story points they complete during each of one of these sprints. So you might have one sprint that only has 1 or 2 story points that are covered. You might have another that has 9 story points that is covered, or 5 that's covered. So they'll have different velocities, and you would have more or less resources typically in the process based on the number of story points. So for simple explanation purposes, if you have a different programmer working on each story point, or a small team working on each story point, then you can sort of add up your resources based on, I'm going to have this many resources. I'm going to be going at a faster velocity in the project because I put more resources into it. And then this phase of this sprint, I don't need as many resources. We don't have as many story points. I can take resources out of the project. So they become sort of building block units in terms of resources. So that really helps the project manager for the development team decide, where do I need people based on the velocity of the sprint during this phase, and what would it take to go faster if I need to go faster. So now that we know the basics of traditional and we know the basics of agile, what's hybrid? And I would argue that almost all projects ultimately are hybrid, even if we don't manage them and call them that. The reason why I would say they're hybrids is because, like I said, in the middle of the development process for medical devices and IVDs, we are trying to decide which of these which of these risk controls we're going to implement. What is the best risk control? We might be doing formative testing to evaluate different user interfaces and different ways of instructing somebody to do something, different diagrams, different knobs, buttons, controls that we would try, different displays of information on the graphic user interface. So each time that we try a different approach, that's another iteration that's going to be in the middle. Up front, in the project plan, we come up with an initial project plan. That project plan will change. It will get more detail over time, and it will probably slip in terms of schedule. We said, oh, it's going to finish by this date, and next thing you know, it's 6 months later or a year later that it's going to finish the project. That's not uncommon. We want to improve our quality, the quality of our project management teams, so they have less slipping in the project and they're more realistic in their estimations, more accurate in their estimations. But we're pretty sure that whatever they came up with as the initial plan is not going to be the final version that we see when we're all done. So you have to update your plan as you go along and make adjustments. The second thing that you're going to be doing is you're going to be deciding what your design inputs are, and you're going to be approving that list of inputs. That list of inputs can change. Do not feel like that's sacred once you've approved and you can never change it again. That's not the case. Every single time you go through an iteration in an agile cycle and you're adding a new software requirement, you just added a design input. So it's not uncommon. And when you have something fail, you realize, ooh, we forgot to put that as an input. And you're like, oh, well, the user said, I want wireless connection. I want to get this by Bluetooth. I want to connect it with our hospital information system. That's a totally new requirement and new design inputs. Now you have cybersecurity requirements, and you have security with the hospital information system you got to worry about. You got to approach a lot of things differently when you have something that's going to be internet connected. So those are all new software requirements you've got to add. And it's going to be a fairly lengthy list, just adding on Bluetooth, for example. So that's an example of how the projects get more complicated. I get a chuckle here. Raphael's saying the snowball effect here is real. Absolutely. So as we're going through these projects, and we're adding features because the customer said it's missing this, or you've come up with a better way to do it. You might say originally, well, we're going to steam sterilize the product, and then realize one of the components isn't stable under heat, and so you got to switch to a different sterilization method. Maybe originally you had packaging that was flexible, like a Tyvek pouch, and then you realize the product isn't protected enough, and you got to go to a blister pouch that's a little stronger. Maybe you picked a material that degrades with oxygen or moisture, and you got to put it in a foil barrier. So maybe you have to do 2 steps of sterilization. You do one method that's a gas, like EO sterilization, and then you do a second sterilization that's gamma. It depends on what's in the package, whether even the product is sterile. It could be another matter altogether. And you might have an original version of the product that's for prescription use, and you might have later it's an OTC version of the product. Might have very different user interface, different technique of use, a little bit easier to use, some things that are sort of pre-prepared for the user in an OTC version, so they can't make mistakes and they don't have to measure things. So you got to keep in mind what's going to change on those inputs before you get into development. Then you're going to have that iterative product development cycle, and then you have your V&V testing, verification and validation. A lot of 510K products, we just lump V and V together. When you have IVD products, you probably want to separate them into verification and validation, because clinical testing is probably going to be required for an in vitro diagnostic. And if you have a high-risk device like a de novo or a class 3 PMA product or a high-risk device of any type, you're probably going to have some clinical data. They don't want you to do anything that can hurt a patient in a clinical study. So you got to finish all your electrical safety testing, your biocompatibility testing before they'll let you get into the clinical testing. And you have to submit that verification testing as part of your IDE, or investigational device exemption. So now you have a break. You've split your V&V phase into verification and validation, 2 separate phases with an IDE approval in between. So now it just got a lot more complex. And then after we had the review, then we commercialized the product. Now, the reason why I said it's a hybrid technique is because we have iterative processes where we have to go back and add things. We have to add design inputs. We have to change outputs and add outputs. We might fail verification tests and have to go back. But at the same time, for financial reasons and regulatory reasons, you may have very specific stage gates that are critical. One of those would be obviously an IDE. If you have to do a clinical study and it's a significant risk study, you're going to need an IDE. You probably don't want to go changing it and have to do 2 clinical studies. So there would be a stage gate there. We got to finish all our verification testing successfully before we go on to the clinical piece. But if I have software as a medical device, I can change that and redo that verification testing over and over and over again before I go to clinical, and it won't cost me much because it's software. But if I've got something that's an electrical medical device that has to do electrical safety testing, there's very few things I want to change because I'm worried about changing the electrical safety. I can change the software in the medical device, but not change the let's say the power supply, not change the housing, not change my circuit diagrams and where I've got optical isolation. There's certain things that I want to change because that would trigger retesting $60,000 expenditure on electrical safety testing. I'll read a couple more points here. Raphael has some great chat. Thank you, Raphael. He said he had a project come over, a part over from adhesive biocompatibility issues. So it came apart, I think is what he's saying here, because the adhesive, so we have a lot of cyanoacrylate devices that cause skin irritation, very common for an adhesive. So that can force you to retest on your biocompatibility and change the adhesive. So that's pretty common. And he was saying that product actually already had a 510K. So it happens on even existing projects. Sometimes you'll get like orthopedic implants will have nickel allergies. So they'll come up with a new version of the product. It's a titanium version instead of cobalt chrome, for example. So it's very common to say we're going to have stage gates so we don't have to spend a lot of money on a clinical study twice. We want to do that once. Another reason why you might have a stage gate is I don't want to go into electrical safety testing without having everything locked in. So we have what we call a design freeze. That's before the verification testing. You might also want to freeze your instructions for use and your design user, your product user interface before you go into human factors testing, because let's face it, some of the human factors testing bills, I've seen $200,000 and $300,000 for doing a human factors study on an over-the-counter product for an IVD for like COVID. You don't want to be spending hundreds of thousands of dollars on a human factors study twice. The first time will get you in deep trouble with your boss. The second time will get you fired. So you need to be realistic about, well, we've got to nail this down. Even if it causes a slight delay, that human factors study is not going to be months long. It's going to be weeks long. So I'd rather have a week's delay and not spend 100, 200 grand twice. So certain things you want phase gate approach to conserve resources and not spend twice. And other things you want to be more flexible because you can do it in a virtual environment, a sandbox. You can test it. You can do formative testing where it's a lot cheaper instead of your summative validations. And that's a really great way to approach project management is where can we be flexible and iterative and try different solutions out to come up with the best answer and get customer feedback before we commit all our resources on a pathway. And where do we really need to make a final decision before we go to the next step? And that's an important distinction. And it's not always the same answer. If you have a 510K pathway and you have a device that has very well understood technology and you know what the testing plan is going to look like, you may not even need to do a pre-sub. You may know exactly what tests you're going to do, exactly which labs. You may already have pre-approved protocols for everything. But if you're jumping into a more fluid situation like a de novo product, you're in developing your own special controls for that product. You're working with the FDA interactively about what testing is required, what things not, and you've got to figure that out before you go ahead with that. So it's a very different type of project profile when you're managing a project that is very well defined, has very well defined inputs, the product requirements like a 510K with a special controls guidance versus a de novo that doesn't even have a guidance, doesn't even have a product regulation yet. And there's no other competitor product to benchmark it against a lot of times. So very different styles of project management for those two projects. And what you might do for a product improvement where you already have a product on the market and you're trying to make something better or solve a pain point for customers, that's very different. You might have fewer phases. You might jump right into the phase 3 and skip phase 1 and 2 and just combine 1, 2, and 3 all together. That might be something you do. So having a different style of project management for different phases is what you should do. And you should have that flexibility in your system. There's one other thing that you need to keep in mind here, and that is a lot of people like to put everything in a big Word document, and they like their spreadsheets. Word documents and spreadsheets are what was developed in the 70s. I was using them all the time, every single day in the 80s. So that's even older than design controls. So there are newer tools that use these really cool things called cell phones and tablets. And they can be shared with your whole team all simultaneously. And some of them are free. So start taking a look at tools like Asana, Monday, Rike, ClickUp. I'm trying to think of other ones out there. There are a lot of great project management software tools out there that you can use, and they all have their little nuances, what they do better, what they specialize in, what they're known for. So, for example, we use Asana a lot. That has a list view. That's usually where you jump right in. It also has a more traditional Trello board, for those of you that know Trello or Basecamp. So that's more of a, you have these boards that you move from one stage of the process to the next, like to be done, in process, finished. And then we have Gantt charts. Monday does a great job. Rike does a really great job. Those are tools that give you traditional Gantt charts. So if you want a Gantt chart, you would use those tools. If you want more of a board, there are other tools that can do that as well. So you got to pick the right tool for your team. Some of them will allow you to share for free with guests. Some of them won't. That's like an important consideration. If you're developing a product and you have your contract manufacturer involved in the project and you want to share stuff with them and have them participate in the project management activity so it moves faster, usually that connection between you and your suppliers is critical. So having free, making it possible for them to participate for free in that project and not all your other projects, just that project, is an important consideration to keep in mind for your selection of software tools. And you want something that's going to work the way your company works. So you want it to communicate with your email, and you want it to be a place where you can share documents. You might find a lot of neat ways that you can use it to improve all kinds of administrative processes, not just your design process. So don't just get feedback from the design team. Get feedback from other departments too. The sales team could use it to manage their sales funnels. I know Monday has a Monday CRM. It's basically their Monday project management tool that they've added on some special templates to make it user friendly for the sales team to manage their customer relationship management process. So you want to decide what is the right software tool for your team and then implement that. We have some more comments here from Raphael about human factors. Early OTC hearing aids, which were in my intro quality 10 years ago, most proved self-fitting and dispensing was in fact no more dangerous than what was done by a pro. But it was really costly and no FDA precept. So I actually know the person that actually submitted the original OTC documents with Bose to the FDA that now has made it possible for hearing aids to go OTC. And you're right. There a lot of the fitting that was done by professionals can be done OTC. There's a lot of things that can be done OTC out there, but what we already are having trouble in the medical device industry managing projects, period. Documenting design controls. I can't tell you how many companies get all the way to their final version and haven't documented any design controls and have to do it retroactively. But then they don't have a risk management file. They don't have a usability engineering file. They aren't trained on risk management adequately. They're not trained on human factors, and they're not trained on clinical studies. So all these things are things you have to master, and it's become so complex that we need a multidisciplinary team just to get through the process alive. So you really need to make sure your team is multidisciplinary and you have subject matter experts in each of these disciplines, and they all communicate really tightly so you keep your project on schedule. And that becomes absolutely critical that you have the right project management tool and everybody's going in there and updating it regularly and communicating. You want to over communicate in those channels, especially if everybody's working from home remotely, which is the norm now. So that's made it more complex. Work is global, work is remote from home, work is digital and virtual. And that's changed the game for everybody. It forces us to use these new project management tools, and you're going to see a lot more from our company about how to do your project management better. And we'll give you examples and give you some tools out there and show you what we do ourselves, because we use project management tools for everything, not just our human factors projects and our design projects, but just things like onboarding a new employee, making sure that we plan a new webinar that we're going to do. We use project management tools for everything. And it really is, we're finding the more we use it, the happier we are. It's not a burden, it's actually saving us. So it's making us more productive, and we recommend that for you. So I hope you enjoyed this. If you did, please share this with other people and let them know about this project management webinar. We haven't done really a lot on project management, so I'm going to create a new playlist for this. And if you have any suggestions for future ones, every Friday we do a live streaming. So I'd love to have your suggestions for a new live streaming in the future or any other webinars. And we also have our suggestion box page you can go to. So hope to see you soon. And any comments you have, I always answer them on Fridays after I do the live streaming. So I'll be checking out comments and answering them today. And any ones you put in this week, I'll answer next Friday. Have a great weekend. Bye-bye.